I will explaining about the modern tools that we have chosen for this project. As for this project, we have chosen Ansys software to validate the natural frequencies that have been calculated theoretically. First of all, we need to double click on the model and right click on the geometry and click the edit geometry in design modeler. We need to sketch our design in this design modeler. For the first sketching, which is refer to the first block, we have calculated the dimension that is 549.15 millimeter. So the length and the width will be the same. And for the second block, the calculated dimension is 519.41 millimeter. Next, we need to right click at the model and click edit, and it will appear like this. We need to ensure that the material that we have chosen is correct, which is structural steel. Next, we add the connection on the block. For the first connection, we add the spring that attach ground to the solid. The first spring stiffness is 200 kN per meter. And we have choose the reference X coordinate is -500 mm. For the second connection, it will attach between solid to solid. And the second spring stiffness will be 400 kN per meter. And lastly, the third spring will be attached to ground to solid, and the stiffness will be 600 kN per meter. And the reference X coordinate is 1200 mm. Then click the analysis setting to set the max mode to find is equal to 2 because of there are 2 mesh. Lastly, by clicking to the solution, we can see that the natural frequency will be 2.6768 and 5.2491, and it is the same as the theoretical calculation. From this, we can determine the mode shape by dividing the maximum and minimum value of the mode shape given. And next is for the second design. For the second design, it is still the same as first design, but for the spring stiffness will be different. Spring stiffness for the second design, all of the spring stiffness will be the same, which is 300 kN per meter. Then the same step, we need to click on the solution, and it will appear the natural frequency for this design. And we need to click at the total deformation to obtain the mode shape for this design. As you can see, there are the maximum value and minimum value. We need to divide it to obtain the mode shape for this design. That's all from our group. Thank you.